Hello guys. My name is Zahria Duncan, and I'm a Tuskegee University undergrad student, majoring in environmental science with a minor in material science and engineering. And today I'm presenting a project called the development of 3D printing technique for chicken feather powder infused with biodegradable polymer films from the Department of Material Science and Engineering from Tuskegee University. At my university, we had a thing called Fried Chicken Wednesday, and as you know, fried chicken's pretty good. But anyway, I always wondered what do they do with all them extra parts that we eat that we don't eat from the chicken, which including chicken feathers. As current research shows, a current adult chicken can have up to 125 grams of chicken feathers, and the weekly worldwide production of feather waste has been about 3,000 tons. Disposal of this bulk waste is a global environmental problem, accounting for pollution of soil and groundwater sources. There have been many unuseful ways to dispose or remove chicken feathers from facilities like incineration, they bury in landfills, or they recycle into poor nutrient animal feed. And incineration, which can cause CO2, which enter our atmosphere and cause greenhouse gases issues. Buried in landfills, if the chicken feathers come in contact with blood, which they more likely will be, and they end up in a landfill, and the landfill may get a leak, and it might enter a water system where people might drink from that water system, and that could be a contamination issue. And just poor nutrient animal feed is probably not a good nutrient for animals. So me and my partner Zahir Muhammad, we're trying to find a way to incorporate chicken feathers into a biodegradable polymer called EcoFlex and see if this could be used for future projects like food packaging. This project can be useful for the community because chicken feathers can come in abundance and we can reduce the impact we have on the environment by removing chicken feather and using their property in composition for many uses. So to begin with that, we start with methods and materials. We first had to clean the chicken feathers. We did a process where we like remove outside elements. We washed it constantly in distilled water, tap water, and we used neutral soap to remove other things like dirt and stuff. And then the next step, we ball mill, which is a process which reduced the chicken feathers from the previous picture into a powder. And this powder was measured with EcoFlex and chicken feather in certain ratios, and that ratio we magnetic stirred it with chloroform to make a soluble solution, which was used to be able to 3D print into films. And these films was tested using mechanical testing and thermal testing. So my results from them testing was, well, first on the far left we have a SEM image of chicken feather powder, which shows fibrous properties, and as fiber properties, we got this idea from the keratin that chicken feathers are made from, which are 91 to 93% of their composition in total. So next is the mechanical properties. Mechanical properties, as you can see, the neat EcoFlex, which means no other outside element, just EcoFlex in core form, perform poorly against the 6% of chicken feather powder incorporated with the EcoFlex in core form. And then in thermal properties, as you can see, neat didn't perform as well as 10% of chicken feather powder incorporated with the EcoFlex in core form. So from them two studies, we can conclude that chicken feather powder can be used as a useful filter for improving the mechanical and thermal properties of biodegradable polymer films, which is EcoFlex, which better and with these results, it came with some issues because maybe the interface and the proper dispersion of properties can be further improved. So in this future work, we aim for this project to look for proper antimicrobial properties of these films, so these films could be infused with chicken feather powders and could be used for food packaging applications. So I would like to thank the National Science Foundation APCU grant and the Tuskegee University Poultry Farm and my current advisor, Dr. Regari, and Mr. Zahir Muhammad, my student mentor in Tuskegee University. And that's the end of my presentation.